Hello, in this section 3.2, we're going to cover some of the key functions such as map versus flat map versus and also pair RDD and also reduce by key. Okay, let's get started. Map versus flat map. So map is a function, right? That means it's actually a transformation. So you can actually see if you have an input file, you can actually create your input file by writing it like this, right? So to percentage, right? And then write file, input, this is the name that you want to assign to this file. And then you can write a bunch of text. This is how you can actually write some, data into a file. It's called input.txt file, and then you can do a bunch of transformations and member actions, right? So the first thing what we can do is like this, right? So this is a usual map. So what is this doing is I want to do, remember SC is our Spark context, right? And then we want to say text file, that's kind of like reading this text file, right? So because we already save it as, input.txt, right? So doing this, you can actually see it's just pretty much partition it to RDD. So we can actually call this, like what we did before, RDD, right? So this is to parallelize a text file, and then RDD, if you look at .collect, right? This will collect everything. You can actually see, okay, so this is actually in a list, right? So a line, so it's reading line by line, and then each line will become an element to this entire list. And then we can actually do something like, okay, so with this in mind, we can actually do split it, right? We want to say split it by space, right? So remember how it looks like right now is one sentence, right? So we want to say hello world, another line, so split by space. So how do we do that is we can actually use this function again, map, right? Map, remember, is a transformation, right? It's not action, right? So it is still, that means this transformation is done in silo, right? In many workers, right? Worker nodes. So you can actually do something like that, split, right? Remember, this is kind of similar to what we had in Pandas data frame, right? So X, right? To X dot split, right? So if X is a string like this, you can split it by, by putting the space or just do split, right? So if we look at this, right? So assign is to RDD2. And now we can do a collect again, to dot collect is equal to, okay. So now you can see that this is a list of lists, right? So every sentence now will become a list, and then all these sentences are, all these lists are actually in this bigger list, right? So it's a list of lists. So that's how we actually got to this end results, right? And by doing first parallelizing the text file and then mapping it by splitting each line with the space and then do the collect. So that's great. And then what about flat map, right? Flat map is another function, right? Notice that this is lowercase, f is lowercase, and m is actually uppercase. You can see that the difference is that actually it's flattened. That means it's not a list of lists, it's just a list, right? So that's actually the main difference, right? So map, remember, it's going to give you back a list like this. Flat map is like it gets flattened, the results gets flattened, right? So therefore you're gonna get a list. So if we just do something like this, right? Yeah, I mean, I was gonna do it one by one, but I think this is pretty clear that the difference between flat map and map. Okay, let's talk about RDD, right? Pair RDD. So the same way that we wrote the other text file, we can actually do this, right? And then we want to actually create the sales.txt by doing percentage write file, and then give it a name, and this is the data we want to write. So let's go ahead and write this, right? So now we have this. And then let's do the simple sc like in here, right? So sc dot this is a function that we can use text file, and then we can actually put the name of the text file. And then this will parallelize it, and then we can actually do top or take, right? So this will actually give us the top two, right? And then the difference between top and take is this, right? We can actually do top two. So you can actually see take is like, it's actually grabbing the headers as well like this, right? And then top is not giving us, it's giving us the top two rows without the header, right? So that's kind of like a difference. But you can see that, like this is how you can actually look at the data. And then in here, right? So we have, we can actually split this, right? Because right now, pretty much one row is actually one huge text. If you look at this, right? This is actually a text. So what we can do is we want to really split this by space so that, it's going to be date, and then this date is one column, store is one column, and state is one column, and so forth. So this is how you can do this, right? Remember map and then lambda x to x dot split is how you can actually split a string like this, right, into a list. All right, so we can actually go ahead and do this. This is how we can actually we can actually do maybe top, top 2, right? So this kind of like the difference between this and this, right? You can actually see now it's a list of lists. Previously it was just like 2 lines, a list, right? Now it's like all this is split into another list. Okay, that's great. And then what if I want to remove, this thing, pound sign, right? And then you can actually do it by filter, right? So this is another function I can actually use to filter anything else. So the first 2 lines are the same, right? And then we're adding this dot filter and then do lambda, right? It's a lambda. And then x to not, right? X of 0, right? Start with, this is another function I can use. So it's not, if it doesn't start with this pound sign, then we want to take it, right? They don't want to collect it or take it. So that's how you can actually only get, you can actually just do dot top, but if you want to use take and then without printing out the headers, then this is how you can actually do it, right? Okay, so we can actually do it like this, right? Okay, great. So that now, like, what if we want to do something like, okay, so now we have 2, like this, but we want to only grab, the last column, which is amount, right? Amount is the last column, so 300 and 450. So this is how you can do it, right? Up to here is all the same. Like you parallelize it, map it so that you will split a string into a list, and then filter, right? So that you don't print out, you don't want anything that start with pound, and then you want to do dot map, right? So this is to say that I only want to do grab the last one. So X now is going to be a list, right? Because you're mapping a list to the last element of this list, so that you can actually see the input to this map is actually this entire list, right? This entire list. But I want to actually only grab the last element. So that's how I can get to 300. And then I can do dot take 2 to get me to the first 2 numbers, right? So if I actually do this, right, you can actually get 3, right? Right? You can actually get a list of like 300, 450, 200, and so forth, right? So now you can actually do some sort of conversion, right? Convert float to, and then sum it up, right? So because right now this is in a string format. So what if I want to sum up, right, all the amounts, the total batch amount, right? So the way you can do this is you can apply this float, right, around this this mapping, right? So that each element will become float first, and then do dot sum. Remember, dot sum is actually, you can actually do dot sum or do dot mean. What if I want to look at the mean or minimum? Right? But we can keep it, just a sum. Okay, that's great. And then next, we're going to talk about reduce by key. So this is really, really important and a key concept, right? In Spark. So what if, the question is, what if I want to calculate revenue per state, right? So remember, the data we had was like this, right? You have amount, which is the revenue, and then you have the state, right? The state can appear many times depending on the store, because this is a store and date level, right? So what if I want to summarize by state, right? And then so how do I do that? So at some point I have to use some sort of group by and right? So then the answer is up to this point, filter, right? This is the same as before, right? And then you can actually do, instead of only grabbing the last one, I want to grab this the column that's going to be, so this is -1, -2, -3, right? So that's how you can actually slice a list. So I want to grab this column, so that's how I got to this -3, right? I want to map x to a tuple of x -3 and then float of my x -1. So this is how I can actually get only the state, right, and getting rid of everything else. So only to almost like select the state and then the revenue amount. And now I want to use reduce by key, which is another function that you can use, right, in Spark. So up to here it's all the same, right? Map. So now you have this list of tuples, right? So then you can do dot reduce by key, and then you can put lambda of amount1, amount2, map to amount1 plus amount2, and do dot collect. So the input to this reduce by key is actually a tuple, right? And then when you do this, lambda of amount1 and amount2, it's going to know the first thing, right? It's going to know that you want to reduce this. So the first one is going to, the first element is going to be treated as a key. So you want to reduce it by key, right? And then that means I want to aggregate by this first column, right? And how do I want to do the aggregation is actually is just by add them up like this, right? So if you run this, you can actually see that C8, right, it's treating the state, the first column, right, as the key, right, that it wants to use to reduce. So think of it as like if it's SQL, then it's going to be what you're trying to use to group it by. And then if it's Pandas data frame is, PD, like a df.group by, right, what you pass inside this group by, right? So that's like the key that you want to, by using this, it will always recognize this first thing, this first column as the key that it's going to be using. So, right, so what if I want to do something like, times, right? This will give us, right, this will give us like 300 times 750, right, to get the value for WA, and CA is going to be like all the numbers, the product of all the numbers. But that's not what we want. We only want plus, right? So this will give us a summation by each state, right? So this is actually a very important concept. Okay, so then we want to find out, the state, find a state with the highest total revenue, right? So we have all this, but what if we only want to print out, sort it by the total revenue, right? So up to here it's going to be the same, right? Reduce by key, but remember we have this another transformation that's sort by, right? Dot sort by, and then we can do lambda of state amount, right? And then to state amount of 1. So we want to, what we want to do is we want to sort it by the second element. Remember, what we're putting in is really this tuple again, right? But what we want to sort it by is actually the first. So this is our first position, which is going to be 0, and this is the second position, which is going to be 1, right? Because remember, the list slicing of the list, it starts from position 0. So if we want to actually sort it by this value, right, this revenue value, that means we'll have to do amount. We want to map amount, right, state amount to state amount of 1. That means we want to use the second number, right, as the sorting field, right? And ascending is equal to false, right? What if we do, then this is how we actually get this, right? So WA is the highest, right? You have the highest total revenue, and CA is second, or is, third. So, but then what if we want to do something like, okay, so I don't want to sort it by the total revenue, right? I want to sort it by state, right? So we can actually just change this to 0. And then this will give us, yeah. So it's going to be ascending, that it's actually going to be alphabetic, but it's going to be descending. So WA is going to come up first, right? So we can actually delete this. Then we can actually look at, it's going to be, yeah, C, it's alphabetic order, so it's going to be the first and second and fourth. But it makes sense to actually sort it by total revenue, so we can actually do it this way, right? So that's great, and you can collect, or you can, what if I want to do mean of it, right? So the mean of that, yeah, it wouldn't work in a way that because we are selecting, because the input to this is actually the entire tuple. So what if I just do map, right, of lambda, and then x to x of, 1, right? So I only want to output this number and then do the sum, do the mean or do the sum, right? And then this is to just change the line. Okay, so this, you can actually get the mean or you can get the sum, right? So this will give me the sum. So 730 plus this, all the sum. Yeah, it looks right. Okay, so that's pretty much it. And then we can actually do a quick exercise for like a word count, right? So what if you have like all this using the same input file? You have all these like hello world, another line, So I want to count the words, right? So this is actually a very popular problem. So the first thing, right, we will parallelize our text, right, our file, and then we want to flat map it. Remember, this is the key, right? So it's going to be a list. It's not going to be a list of lists. And then dot map. So this is to say, actually, this is pretty important in a way that we want to assign a number to every word and then use word as our key, right? So this will give us hello, tuple of hello, and then one world hello, and then one, and then another and one, right? So it's gonna convert all the words to tuples with this one, right? And then we can actually reduce by key. Now the key here is gonna be the word, right? And then we'll do the same thing, count 1, count 2. It doesn't matter, you don't have to do count 1 or count 2. You can actually do just A and B or X, Y, right? So this is just a variable that you assign, and you can do the summation of it, and then this you can then do the collect. So let's take another look at this, right? So we can do something like this. So we know how this looks like up to this point, right? So we can assign RDD into this. So RDD is equal to this, right? So let's look at RDD. So we can actually do dot collect. Okay. So you can see that because how we have described flat map is going to give us lists, right? It's not going to be a list of lists. Now we can assign this to RDD2, say, right? Not collect, just the right RDD, and then we want to do is RDD.map, right? And then lambda, again lambda, and then word, and then we want to map this to a tuple word, and then it's all just one. Right, so and then we can actually do dot collect, and then we're gonna assign this to RD2 later. But and then you can actually see word 1, hello 1, world 1, another one, that, right? So then we want to assign this to RDD2, right? So it's a list of tuples. Okay, now that's good. And then what if I want to do then RDD2 dot reduce by key, right? You can actually auto tap it into autofill it, and then what I want to do is lambda of A, B, map to A plus B. How it knows, because the key here is that you have to put your key as the first element in this tuple, so that Spark will know that that's going to be the key that you're going to be using to reduce, right? So what if I do this and then do collect, right? So this will give me, you can actually see, okay, let me just print out RDD2 as well so that you will know RDD2 dot collect, right? So RDD2 dot collect is just like, you have, another appears many times, but it's every time you're actually doing another and one, right? But in here, reduced by key, you can actually see another is actually being aggregated, right? So it's like 1, 2, 3, 4. It has like 4 counts. It has 4 tuples. Therefore, it's going to be another is being 4. So that's how you can use reduce by key to do the word counts, right? So let's say we want to assign this to, yeah, I mean, that's pretty much it. We can assign it to RDD2 or just do the collect, and that's the same results as, as in here. I mean, that's pretty much it, all, the key concept, right, of using the key functions. So we covered map versus flat maps, and then as well as reduce by key, as well as writing some data into a text, right? And then we talk about also a very important thing you can actually use to, to do like this, right? You can actually do a lot of aggregations by converting a string into a number, right? That's it. Thank you.